Today is 29th of February 2024. Okay, and this will be our sixth video on the histogram. Thank you so much to all my subscribers and everyone who is following, helping, share, like, giving us comments. Thank you so much. Okay, if you've not considered subscribing, I don't really know what you are waiting for. Okay, but if you are enjoying our platform, consider subscribing or following us. Okay, I appreciate that a lot. And when you get the video, share it as well, like it, comment on it. Okay, if you comment, it helps me as well to see what I can do better, okay, to help those who really want it. Okay, please follow my notes/scripts. You always see this in the comment section because it's very important. So for instance, this is 6 minus x. Okay, that's 6x. Okay, so if you hear anything apart from that, please follow the notes. Okay, I appreciate that. And if the account is not yours, please, ask Richard from the account holder. Don't use somebody else's account. Put comments on there, and they have to defend it if it's not good comments. Okay, recap. Watch last video for recap. Okay, we've been doing histogram work. I've brought different kinds of examples that you can have a look. Okay, these are exam questions that I have picked and then looked at it, solved it, and brought it to you. Today is also a histogram, but another type of question. Okay, even though we are going to find the median and the more interquartile range, the lower quartile and the upper quartile, there is something interesting I need to show you. Okay, so watch all the videos, watch all the examples, so that if something comes, you can solve it. Example, our starter. Okay, this is another foundation non-calculator paper, and this can also come in the higher paper. Okay, so the first one, it says 6, they give you 4 of these, and then they ask you to circle one. Okay, and then maybe they write 6 less than x or 6 more than x or something. Okay, so the first one here is 6 minus x. Okay, so you can, if there is 6 minus x, then you go by this. If it's 6 less than x, you can also go by this, because if you take s from 6, you have 6, okay, less than x. Okay, so you can also x less than 6. Okay, this is what I've been saying. Okay, so you can also have x less than 6. Okay, this is different from this one here. x less than 6. Okay, but this one, if you subtract x from 6, you can have x less than 6, or 6 minus x. So whatever answer they are asking you, you can choose between this or that. If this is what is there, then that will be it. Okay, now the second one is 6 times x, 6x. So it's either 6 multiplied by x or 6 times x. Okay, so you have to look out for what they're asking you to do and circle the right one. Now, x over 6. So this is either 1/6 of x. Okay, so 1/6 of x can be 1 over 6 times x, which will give you x over 6, or x divided by 6. X minus 6. Okay, so this will be 6 less than x. Okay, so if you take 6 from x, then you have 6 less than x. So you can have 6 less than x here. Okay, there. And then when you swap it around, x is greater than 6. So think about it. Because x is greater than 6, you can subtract 6 from x. There, this one. Okay, so it's either 6 less than x or 6 minus x, or 6 less than x is this one here. Okay, or 6 greater, because if you flip it around, then it will be x greater than 6. Okay, so go over it this starter and have a think, especially the foundation students. Okay, and at this stage, I'm speaking to all students as well, because if this came in the higher paper, maybe it was the first question, and it confuses you, then you are going to be mad because these are questions that come, and you might have to think a bit deeper before you answer them. So go over it as well. Now, as you can see, graph work can be very easy to do. Okay, and at times you just need the principles, understand the question, see what they're asking you to do, and then you do it. We've done the cumulative frequency curve, the O-curve, and now we are looking at the histogram. Okay, so this is another question. Last lesson we saw a sample space that was odd. Okay, now 220 is even 180. So if I want to find the median and I find half of that, I'm going to get an even number. If I find 1/4 of 320, I'll get an even number. And if I find 3/4 of 320, I'll get an even number. Okay, these are things you have to project up front when you're looking at graph work. Okay, because immediately they ask you to find the median, the upper quartile, the lower quartile, the interquartile range, then it means that you have to consider the total frequency or the sample space. Okay, Now, in this question, the graph was given, so I had to create that. All the graph was given, so I had to create a table, okay, to get my information out. So I used the graph to create my table. So this is what I was given in the question. I'll show you the graph, okay, without the, let me zoom in closer, okay, and let's discuss the graph, okay. So here is the graph. All I did was expand the x-axis, okay, so to get a bigger diagram so that I can read the scale. As we said, use a scale that you can easily read, okay. So here the graph was shortened, okay. So whatever I get on the x-axis, I need to add it to this 70 here, okay. It didn't start from 0, okay. The graph was shortened. So here, if I got if it is 10, and then here another 5, then I need to add it to 70, not 0, because my x-axis is starting from 70. And then I managed to get it to 150, okay. Now the frequency density, the y-axis, here it was up to it was up to 6 here, okay. So yeah, so I need to change this part of the graph, okay. So I can change it now. It's not up to 5.5, it was up to 6 there. I'll use a ruler to draw it later. So this is how the graph looked, okay. Yeah, okay. So this is what it is there, and then I have a histogram of year 11 scores. This is my date, 29th of February 2024, so that for my reference, okay. So these are 320. If you finish, your total frequency should add up to 320, okay. So I just recopied the graph and brought it back to show you, okay. So this is the graph here, okay. This is not 5.5, it's 6. I'll use a ruler to straighten it up, okay. So y-axis frequency density line, the highest is 6, okay. My x-axis 150. So from 70 to 80 to 90 to 100 to 110, 120, 130, 140, 150, okay. So this is what I have here. Let me zoom in for you to see, okay. So this is the graph. Okay, so I was given this graph and I use it to deduce the table. So here on the original graph, frequency density for bar 1 is 6, okay, which I have just extended. So first of all, I drew my table here, and then from the graph I did the test scores. So if you can look at it, it's between 70 to 80, 80 to 90, 90 to 100, 110, 110 to 120, 120 to 130, and 130 to 150. Apparently, the whole total of the score was 150, and the lowest is between 170 to 80. So they didn't have to start from 0. So if they did like 0 to 80, there was no point, because between 0 and 70 nobody got that. So everybody got 70 and above. That's what this table means. Okay, then I looked at after getting my test score from the graph, I did the class weight. Okay, so 70 to 80 is 10, 80 to 90 is 10, 90 to 110 is 20, 110 to 120 is 10, 120 to 130, okay, is another 10, and 130 to 150 is 20. So as you can see, assuming we got 10, 10, 10, 10, then we could have drawn the frequency cumulative curve. Assuming they gave us that, but we don't have that here, so they drew the histogram. Okay, now the frequency density is how tall the bar is. Okay, so the first bar is 6, the second bar is 4, the third bar is 5, the fourth bar is 4, the fifth bar is 3, the sixth bar is 2.5. Okay. The sixth bar is 2.5. So now the class width times the frequency density will give me frequency. Okay, so 10 times 6, 60. 10 times 4 is 40. 20 times 5 is 100. 10 times 4 is 40. 10 times 3 is 30. 20 times 2.5 is 50. Now, if you add all this, you should get 320. So you have 60 add 40 is 100. Add another 100 is 200. Add 40 is 240. Add 30 is 270. Add 50 is 320. So I've done that here for you. Okay. So that is my graph, and that is the table I've deduced. So I've done the table. Okay. Now, with this graph, you didn't need to do the table. Okay. They've given the graph so you can go straight away to solve the question. But I use the table to draw the graph so that if they got a question and they ask you, because it's not always they'll say to you, find the median, the lower quartile, the interquartile range. Okay, at times they'll just ask you to do a table of class width and frequency density. They can ask you to do that, okay? Or they can ask you to complete the table from the graph, okay? Especially like the foundation student, they can ask you to do that from the graph given, okay? But because of our learning, I'm looking at all the possible ways that you can use your graph, okay? So now, the summation or the total frequency is 320, as we've been told from the graph. This is even, not odd like odd even sample space, not odd like we saw in the last time. And then they went to say, sorry, and then they went to say, find the median score. Okay, so the median score will be half of the 320 pupils. Okay, it will fall in that range. So half of 320 is 160. Okay, so now let's see how we get on with that. So with 160, the first bar, we have a frequency density of 6 using the graph, and then a class width of 10. Okay, so this is the first bar. The graph ends at 6, not at 5.5. Okay, so I'll correct this when I finish. Okay, maybe I was trying to do my topic, so I thought I was leaving a space. Okay, on the original graph, they did 5, 6. Okay, they didn't use 2 boxes. I had a lot of space. I wanted to use as much of the graph as possible. So that's why I have 0, 1, 2, 3, 4, 5, 6. So I denoted 2 boxes. Okay, and it's equal interval. This can be 5 and this will be 6 and that will be 4. You can't do that, okay, as I've done here. Then on the x-axis is 70, 80. So the class width here is 10. So 10 times 6 is 60. Okay, so my first bar is 60, but I want my median score is half of 320. So I'll go to the second bar. Another 10 class width times class density of 4, frequency density of 4. So 10 times 4 is 40. So 60 add 40 is 100. So I need 60 more. So I'll go to the third bar. Okay, my frequency density on the third bar is 5. What times 5 will give me 60, and that is 12. 12 times 5 will give me 60. If you are not sure and it's a calculator paper, use your calculator. Okay, so 12 times 5 is 60. Okay, so now bar 160, bar 240, 100, bar 360. So I just need the 12 of it. I don't need the full bar. That's my median. Okay, so now these are the class width here, which I've circled on the x-axis. So 10, add another 10 at 12, which will give me 32. But look, the answer can be 32, because yes, if I started from 0, 10, 20, then 32 is okay, but I need to add the 32 to 70 because my graph starts from 70. So 32 at 70 is 102. So if this is 100 and that's 110, that is about 102. So my median score is 102 here. So on my graph, this is where my median score will be 102. So we found the median score 102. Okay. So you need to start, you add whatever you get to 70 because the graph has been shortened. Okay. If you drew this graph and your scores is starting from 70 or 80, then you need to add from 80 if you shorten the graph. If it's starting from 0, it's okay. All the graph we've seen so far is starting from 0, so it's okay. But this one is starting from 70, so you need to add whatever you get to 70. I hope you understand that. Now B, it just said find the quartile range. So before we can do that, we need to find the lower and the upper quartile. Now the lower quartile will be a quarter of 320, which is 80. So we go back again. We've already done bar 1 in the median. So we know that bar 1, okay, is 10 times 6, which is 60. Bar 2, we can't take the whole of bar 2, because if we do 10 times 4, we are going to get 100, but we need to stop at 80. Okay, so 4 times 5 will give us 20. Okay, the frequency density is always the same. We need to find that number that will multiply. So if we add 20 to 60, we get 80. So we need to stop there. That will be our lower quartile. So here, 10 at 5. So from 70 to 80 is 10. From 80 to 85, 85 is another 5. Or 10 at 5 here is 15. Then we add that to 70 because the graph starts from 70. That will be 85. Okay, there. So our lower quartile is 85. Then we need to find the upper quartile. Our upper quartile is 3/4 of 320. Okay, that is 80 times 3 times. Okay, so 3/4 of 320 is 240. Okay, because 4 goes into 320, 80 times 3 is 240. So again, bar 1, 10 times 6, the class width is 10. 6 is the frequency density, how tall the histogram is. So 60. Bar 2, 10 times 4 is 40. So we've done 100. We need to get to 240. Bar 3, 20 times 5 is 100. So if you add 100 to another 100, you get 200. Now we are left with 40. Bar 4 is 4. for the frequency density. So 4 times 10 will be 40. So we get there. So on the x-axis, we need 10, the whole of bar 1, the whole of bar 2, the whole of bar 3, and part of bar 4, the first 10. So if you add all that, you are going to get 10, add 10, add 20, add 20, which will give you 50. But your graph again starts from 70, not 0. So if you forget and you leave the answer as 50, it's not right, because even the scores starts from 70. So your upper quartile cannot be 50. Okay, so you add 50 to 70, which will give you 120, which is your upper quartile. Now that you found your upper quartile and your lower quartile, you can find the interquartile range. Okay, so your upper quartile is 120, your lower quartile is 85. So your interquartile range for this graph is 35. Now, unless you've been asked to draw the table under exam condition, I wouldn't advise you. Okay, I drew the table just to show you how easy it is to deduce to use the graph to draw the table and then help you. Okay, so far you realize that with the bars you need to use your x-axis. Your x-axis is very important. Okay, your x-axis is very important, so you need to use it. So you count till you get to half of the frequency, or a quarter of the frequency, or 3/4 of the frequency, depending on what you are looking at. I hope this one also help. We'll do another last video and I'll bring another type of histogram question that we'll look at. Okay, so please subscribe, share, like, follow, nice comments. Yeah, and take care of yourself. Beware of scammers when you are online. Okay, thank you very much for watching today's video, and I'll see you in the next.